Hey everybody, I am actually doing a bit of a bonus video to add to the playlist that we have going on for section 4 exponential and logarithmic equations. And even though I did squeeze another example in there involving factoring, it's not of this form. So when you have an example in the form that I have on the screen right now, right? 2 to the 2x plus 2 to the x minus 12, right? When you have something like that and people go to factor it and they like say at least know, like, okay, I should be factoring to solve one like this. People might mistakenly look for a pair of numbers that multiplies to maybe give you either negative 24 or negative 12, depending on if you're doing it semi-correctly or semi-incorrectly or, consistently with how you might be reading it. And then adds to give you negative or positive rather 2. And if that's how you're looking at it, that you're going to run into some trouble. The other example on the playlist, it's going to have e in it. It's like e to the 2x, and then I think it's like 2e to the x, and something like that in the middle, and then like a 3 at the end, something like that. And you can find that on the playlist for sure. That one's easier because the middle term has a coefficient. Also, the base to the exponential is e, and that is also going to make it a lot bit easier for people to recognize that they should be doing factoring, right? So here, I need you guys to realize that instead of looking for multiplies to give you, negative 24 and negative 12 and adds to give you 2, you're really looking for a pair of numbers, and I'll show you why in a second, that multiplies to give you negative 12 and that adds, what do you think? And adds to give you positive 1. Positive 1. The 2 to the x is actually plugging in for the x of our quadratic form. And let me show you exactly what I mean. So, for example, this is really x squared plus x minus 12 is 0. Now, everywhere that we have an x, bye-bye x, bye-bye x. Well, we also have a coefficient of 1 and 1, so we could maybe add that in there. Now, in place of the x, everywhere that we have an x, I'm going to clean it up, leave a little space. Everywhere that we have an x, I'm going to fill it in with 2 to the x, like that. Now here, 2 to the x to the second is 2 to the multiply x times 2, 2 to the 2x, right? 1 times that, plus 1 times 2 to the x minus 12. That's the original problem, okay? So that is what you're factoring. Rewatch that 10 times if you have to. That really highlights and shows you exactly the structure that we are actually dealing with, okay? So I just wanted to take my time explaining that part so we can get into it. So now let's go. I'm going to set up my double bubble. 2 to the x, 2 to the x. If I multiply like bases, you add your powers. 2 to the x times 2 to the x is 2 to the x plus x, or 2 to the 2x. Last times last, 4 and 3 make 12. I want negative 12, so one of them is going to be negative, but my outer and inner, my middle term needs to make a 1, positive 4, and negative 3. If I multiply these two factors together with FOIL, first times first, right? F-O-I-L. Okay, just to prove it to you, it becomes 2 to the x times 2 to the x is 2 to the x plus x, which is 2 to the 2x. Got it? Outer is plus 4 times 2 to the x. Inner is minus 3 times 2 to the x. Now I'm not multiplying, I'm combining like terms. How many 2 to the x powers do I have? 4 of them minus 3 of them. I have 1 of them. 1, 2 to the x. And last times last minus 12. So hopefully you see that the factoring I just did does indeed work. And we can just pick it up from here and finish very, very quickly and easily. So let's go. So I'm going to take 2 to the x minus 3 set it equal to 0. 2 to the x equals 3. And then 2 to the x plus 4 is 0. So 2 to the x equals -4. Take the natural log of both sides. Here I can't even do that. So this part, no solution, right? And here the x can come out front. So x times natural log 2 equals natural log of 3. Divide both sides by natural log of 2, and x equals the natural log of 3 over the natural log of 2. We love it. It's great. And we're done. If you want to put that in the calculator, you could go ahead and do that and get the answer, the approximate answer from there. But like I said, you can't take the log of a negative, so we throw that part away. It doesn't even reach the status of an extraneous solution. It just stops working. All right? And that's the end of that example. Rewatch that beginning if you need to. This was an example of solving exponential equations with factoring, and it's a little less obvious, and I hope that was very, very, very helpful for you. I know it's a type of example people tend to struggle with. If you have any other requests, please leave it in the comments, and I will do my best to make that video of that example for you as soon as possible. Questions, comments, concerns, and feedback otherwise can also go in the comments. Check the description box for the full playlist with all the details mapped out for you, or check the playlist on the thumbnail on the screen right now. Thumbs up if you appreciate, thumbs down if you hate. And that's it for now. Adios.